Which, as Flo said, is a fantastic segue to our next speaker, my colleague Frederick, who is coming from Canada. And yeah, and we are excited to know more about ThreadX and how does this fit into the global picture.
Yes, and first I start with a joke. I like jokes. So I was working on this presentation, and as usual, I tried to have a little image generated for me by a nameless AI assistant. And the funny thing is that it didn't generate an image for me. It gave me a very detailed prompt and told me to go to DALL-E or some other image generator to generate the image, but the images were boring. But then below, it generated an ASCII version for it. And this is this wonderful mess that we see there. So we had a very shiny AI-oriented video this morning, and I love to damper expectations around AI sometimes like that. Of course, the truth of the power of AI at this point in time in history is somewhere in the middle, right? Better than this, and probably not as good as the video this morning. Anyway, so I'm Frédéric. I manage embedded and IoT programs at the Eclipse Foundation, and I'm really happy to be here today. And today we have a whirlwind tour of automotive open source, the last frontier, and that last frontier being safety critical things that we just covered a bit with Flo. All right, about me, I've done a bunch of things. So you can find me not on X anymore, but on Mastodon and LinkedIn. I'm a serial offender from that perspective. And I wrote a book. It's probably stale at this point from 2022, right? The half-life of books is much shorter in those days. But anyway, if you're curious about the Eclipse IoT stack, this is still a semi-fresh introduction to it. And let's say that I didn't get rich with that project, but I learned a lot. Okay, so the goal of this presentation really is to think. It's from my part, of course, thinking, building it, and from your part, getting you to think about things. And this is, by the way, Thomas J. Watson Sr., so the first CEO of IBM, and just wanted to put that picture there. But then I had a problem. I wanted to express the concept of thought in a generic way for this presentation. And you know, once again, I tried to generate images. They were crappy. I could have included Rodin's penseur, but that's a cliché. So why not go with a skeleton? So please meet Cubitus, the skeleton philosopher that will ask tough questions in this presentation and make us think together. And you may wonder why skeletons. Well, this is a running gag in my family. So this is us last Christmas. And as you can see, we had Cubitus there with a Christmas hat and everything for a small family photo. So just a silly thing that I like to do. Anyway, all right. So first question by Cubitus. What makes your favorite car brand your favorite car brand? Really deep to start, right? What would be your answer to that in the room? The price? Oh, okay. Interesting, the price. Yes, I mean, price is an expression of, let's say, the design intentions of a car. And some brands will put very high quality materials to drive up the price, right? And things like that. Excuse me? The color, yes, but once again, I mean, I can buy a boring pebble gray BMW or GM or Lancia, right? Or Dacia. So it all goes, you know, that doesn't define a specific brand, right? Although some colors are quite exclusive to a specific brand. So my answer to this is, of course, there are things that it's not. I wouldn't buy, let's say, a BMW because it's got Bosch wiper blades. So it's not about the components. Although, although maybe your car purchasing experience is different from me. But really, the answer to this is that, well, the secret to a specific brand is increasingly in the software, because this is about the driver and passenger experience. This is where you want to differentiate. And when I sit in my own car, I won't name the brand, but when I sit in my own car, I get a different experience than in my daughter's car, which is a smaller car from a different brand. And essentially, you want to get me to buy your car by building something more impressive in those departments. And this includes things like vehicle management and commerce and safety. But please, no more ads. Okay, we're talking about AI all over the place. If your sole goal is to put damn ads in my car, please refrain and leave the working group. I don't care about those things anymore. Okay, maybe not. Maybe that's a bit harsh. But there are other things than just displaying ads. Provide value to me as a driver or passenger, and then we'll agree. If it's just to sell my personal info to someone else, anyway, we won't agree. But of course, secret is in the software, and many of those things are not necessarily traditional embedded use cases because of the connectivity and all of that, which means we don't necessarily need to safety certify all of that, but safety critical, of course, is still important in automotive, and increasingly so because regulations, raise the bar all the time. Yes. And so, when you think about this, of course, over time, all of those things become costlier and costlier, and people don't like to pay more for their car. And so there's been, in the industry, this natural progression between sharing suppliers to lower costs, and this gave us tier ones, and that's a great thing, I suppose, because before everything was in-house, so first step. Then sharing platforms. What do you mean my Mercedes is a Chrysler and vice versa? Yeah. So, of course, that's another way to drive costs down. And ultimately, you want to share an ecosystem so that there are standards and things that you can. And then this provides a more rich ecosystem, a more rich marketplace where to find components that will accelerate time to market and things like that. And our working group here is the next evolution into that, because it's not just an ecosystem, but it's an open, transparent, and meritocratic ecosystem. And that's a game changer from my perspective. And this is why you want this, right? Because in the traditional supplier relationship, this is Versailles, by the way, if you didn't recognize. And so I've been a product manager in the past. And so it's always enjoyable to be a product manager for a product, and then you can say no, you can shut down people asking for features, and you revel in your power. Okay, maybe I exaggerate, or maybe I'm a psychopath, I don't know. But the thing is, right, when you have an open and transparent and meritocratic ecosystem, the relationship changes. And so essentially, you need to be more responsive to the market, and you will be better attuned to the needs of your customers and partners and suppliers, because you cannot act like you were doing in the past, of course. And of course, there's the sweet passage of time, because essentially, the truth is, anything that you have really exciting and cutting edge in any car today will be a commodity 20 years from now. It was quite exciting 20 years ago, or even when I was younger, when I had hair on my head, and my father bought a car with EFI as a badge, electronic fuel injection, and it had an onboard computer with instant fuel consumption. How exciting. Now that's quite quaint, isn't it? And so anything exciting today will be a commodity. And when it's a commodity, then people won't buy your car because of that. And so this is why you need to build those things together in an open, transparent, and meritocratic ecosystem so that you save and have more resources to innovate on top and differentiate. And so this is true in pure embedded, which is my domain as well. It was quite exciting to have an MQTT client in RTOS, maybe in 2005. Now, if I try to excite you with that, let's go to lunch. And so this is exactly what we excel at the Eclipse Foundation, where essentially you have commodities and the value line goes up all the time with the passage of time, and you want to collaborate together here and compete on top of that. We create the conditions for that. But now, of course, you may ask yourself, thank you, Cubitus, what is open source? That's a tricky question, although there are official definitions. I can tell you what open source is not from personal experience because I'm involved in this project. Open source is not this. So this was a good initiative by Microsoft, where essentially they purchased what was known as ThreadX and has become back ThreadX as Eclipse ThreadX now. Code was available, but the licensing model was a mess, and you had to deal with boards and things like that. And People didn't build an ecosystem around it because essentially the rules were too complicated, and ultimately Microsoft was maintaining control. And this is not a knock on our Microsoft friends, but this was probably there was a good rationale, I guess, in the heads of the deciders there. Anyway, it didn't pan out. But it's good for us because this gave us Eclipse ThreadX, and well, rather than killing it, they made it open source. So ultimately, it's a story that ends well. So the lesson there is that open source is much more than just the source code. And a version of that, and I won't spend a lot of time on this, is what you find in the open source definition. And so, for example, people could be tempted to say, oh, our code shouldn't be used in weapons system, or, our code should be used just for rightful causes or things like that. But when you enter into that, you will get lost. And the thing is, open source is about developer freedom there and guarantees those freedoms. So, for example, you could say, oh, our code can be used in weapon system, but only by friendly NATO nations. Well, not all of them are friendly anymore. Anyway, don't get, you have the official list there. Don't get into those things. If you have restrictions on anything, it's not open source. That's the short version that you should remember, okay? And so this brings us to the virtuous circle of open source. What open source brings to us as a community. And so first, it's about the transparency, and this helps us build trust, even among competitors in the marketplace. Then, of course, there's the collaboration aspect, and we've seen that in various projects presenting this morning, essentially showing how we have an adapter for that other project and that kind of stuff. That's collaboration at work. And really, this builds over time a network of people learning from each other, mentoring each other, supporting each other. And this is a true community. Then, of course, there's the rapid innovation and learning. Because you spend so much time together, you will get better ideas over time. And this is the power of our working group here. And of course, then there's the customization and flexibility aspect. And Flo insisted a lot on that in his presentation and answer. Even in hardware, now it's possible through the power of open source. And finally, of course, then you get ultimately cost efficiency and independence because you want to be free from product roadmaps and product managers like I was in my bad past life. And so just to reinforce the point that this is now possible through OpenHW Foundation in hardware too. And by the way, Flo didn't insist enough on this point to my taste. But you have plenty of academic RISC-V research projects on the internet that are open source. You have plenty of proof of concepts, but OpenHW Foundation provide you the only verified industrial cores that are open source in the market. Only game in town for that. And so they have chip verification engineers that spend months executing programs, instruction by instruction, and comparing that to a simulated model, okay, to ensure that this is ready to market. So what this means for automotive, ultimately, when you think about open hardware? Well, three things. First, the flexibility, the fact that you can add instructions or a custom AI accelerator that will work hand in hand with a standard OpenHW Foundation core, or a mix of those approaches. Okay, this was not possible before. Now you have the choice, and that's really important. Of course, the predictability. When you are supposed to maintain a 20 to 30-year supply chain for a specific model or something, it's nice to have the assurance that this core will not vanish because somehow the supplier will say, oh, you need to move to the latest version. Maybe you don't have that need because it's good enough for whatever it does. So once again, open source there at work makes your whole supply chain more predictable. And of course, sovereignty. Should I explain that? Well, if you want certainty about the fact that this IP won't be yanked by an executive order, let's say, then, well, this is the way to go. But can I really trust open source for safety critical applications? I mean, you know, this is important, and I don't want to kill people, which is a noble goal, by the way. Well, yes, you can. I mean, of course, Safety critical was the last frontier of open source up to now, but you've seen movement in the last few years, not just at Eclipse, but elsewhere in the ecosystem, that are slowly making this possible. Of course, this doesn't mean that you will get everything certified in open source or everything available. Flo was saying, well, we're thinking about additional verifications for safety cores that would be members only and things like that, because essentially, safety critical is very expensive. So if we don't have a dedicated revenue stream, just counting on people sponsoring us with 25 euros at a time, we won't get anywhere fast, right? And we want to get somewhere. So we have to be creative as a nonprofit organization to organize that, but we were successful in that. And ThreadX is the only example of this. ThreadX is the only and the first and only at this point safety certified real-time OS. And it's been deployed in 12 billion devices. So if you think, oh, it's a young Eclipse project, I don't trust it. Yes, it's a young Eclipse project, but it's been around since 97, older than Zephyr, older than FreeRTOS. And yet, if you look at the code base, at least if you like to read Mr. highly high quality and well documented as well. And so we've got a bunch of certifications that we will maintain over time, and we have a commitment for that from the foundation. And I'm happy to say that up to now, we've been starting selling access to our safety manuals to bankroll future certifications. We've been quite successful, so we will certify our current version and the upcoming ones hopefully forever. So that's what in the toolkit. I'm not covering this in detail because the point here is to talk about safety critical in automotive, but let's say this is a fairly comprehensive starting point for anything you may dream about in automotive and open source. And by the way, it's also the fastest open source real-time OS that you can find in the market. All details in that nice little report. So ultimately, what we're trying to build here, as Flo explained, and this is a more colorful version, let's say, that we were using at Embedded World, but really this is a comprehensive open source RISC-V stack that gradually Eclipse is building, and of course with IoT and SDV specific application building blocks on top. So looking forward to work with you all. Already at the hackathon, some people played with the concept of Zeno over ThreadX or trying to port your protocol components there and things like that. And of course, we were just playing around, nothing practical or production ready came out of that, but we have proven already this is possible. So the next step, I'm awaiting your PRs for official support for all of those nice things. Okay, but now, okay, you convinced me, ThreadX, okay, but that's still an old RTOS written in C, and I'm a trendy person who cares about memory management. Yes, all right. The thing is, first, ThreadX works with Rust, as illustrated by the next speaker, okay? And, well, my crabs are not as cuddly as the official Rust one, but yeah, just a funny picture. Anyway, all of this to say is that there's proof that we can work with Rust modules and ThreadX. Thank you, Valtech. And then, of course, Rust is not the only memory safety in town. I like the language personally. I have nothing against it, although part of my job is to, well, promote ThreadX, of course. But don't forget that with good static analysis and good tools and MISRA, you're getting close enough already to what you would get. Then, of course, it's possible now with the Sherry extensions in various processors to delegate memory safety to the silicon, which is an interesting approach, which can be used in combination with others. I'm not saying, oh, just put it on the chip and trust that, but that's something that's really interesting to look at from even a RISC-V perspective there. And of course, there are memory safe C compilers emerging slowly, learning from Rust and bringing that to the C marketplace. So, you know, because Rust is trendy doesn't mean that ThreadX is not part of your future. So where do we go next, very quickly? Well, essentially, there are EU-funded research projects that will further research in the direction of, let's say, open hardware, RISC-V plus ThreadX and other open source things. And so I pasted the information there from a nameless project that I cannot explicitly talk about yet because it's about to be public. Damn, if they have sped up things a bit. Anyway, probably in May it will get started and you will get fuller details. And then I will mention in passing that my favorite opera by Verdi is Rigoletto. Just like that. So if you're interested, join us in the ThreadX Alliance. Some, and many of you, in fact, are already members. For SDV members, it's free to join. And then you get the benefits of showing your support to ThreadX. And my call to action for you, get the code. It's on GitHub under MIT license. Do whatever you want. Stay informed. We've got a mailing list. Exciting. And then, of course, join the Alliance. So thank you very much. And if you are interested in ST platforms plus ThreadX, there's a book, not by me, but really a well-done one to get acquainted with ThreadX. And finally, well, thank you very much.
So thank you, Frederick. I was amazed by your slide that you had to justify using C. That really tells us a lot about how things have evolved in the past few years. Because if you feel like you need to justify something written in C for safety relevant application, that tells a lot about Rust. So questions? Questions from the audience online? Do we have anyone? No? So yeah. Oh, sorry, Kai, you're too close.
Thanks, Frederick. So does ThreadX already run on RISC-V?
Yes, we've got support. And it would run even on open hardware designs, but not with support for every peripheral that they would have, let's say, in this nifty microcontroller that they put together. So we need, right now, what I'm trying to do is literally, and this is a nice task, trying to convince my peers at the foundation, including Mike Milinkovic, to invest a bit in this. And so we're trying to find ways to get money to have a full port, but already it works on RISC-V. And if you want to play with it in a QEMU environment, we received recently a third-party contribution to ThreadX. Someone just said, I ported ThreadX to QEMU, would you like to merge my PR? Yes, of course. So you can work with it from that perspective.
A follow-up question, maybe also to Flo. Is that then the intended setup or stack running ThreadX on open hardware RISC-V?
Yes.
My understanding from his talk was that one of the strengths of the hardware architecture of RISC-V was that it would be extensible. I can add more dedicated domain-specific instructions. How would that be reflected in ThreadX? Would I need to adapt ThreadX itself to support that then?
Well, this would be managed mostly by the compilers in the sense that ThreadX is written itself in portable C. So of course, if there are specific peripherals like an open source UART on a microcontroller shipped by open hardware and something like that, maybe I need a bit of code to support that particular peripheral. But since I'm written in a portable thing, and on their end, they have the compiler support to support the new instructions or features in their cores, or even in this case on that microcontroller. Then everything should be fine. We just need a proper port to fully support the peripherals, let's say, but already it would run on it without any trouble.
Okay.
Thank you for asking.
There's a question. Okay.
Since you mentioned TRAP-C as a memory-safe alternative to Rust, does ThreadX compile with TRAP-C?
I didn't try yet.
Because TRAP-C describes itself as C adjacent. It removes some keywords. It adds some few. Union being gone is probably a bigger problem for any C code base.
Absolutely. And then what I would comment on is I didn't test it. I certainly keen to test it at some point. But at the same time, what I wanted to illustrate there is that there is growing diversity in approaches towards memory safety. And personally, as I said, I have nothing against Rust. I like the language. I like the community, the fact that it's under vendor-neutral governance at the Rust Foundation, etc. And at the same time, you cannot throw away millions and millions of lines of code of C that are lying around, lurking in every ecosystem. So having the proper approach where you pick the right tool for a specific job is the way to go. But what I expect is that if, for whatever reason, TRAPC doesn't compile ThreadX or is not mature enough, that some other alternatives will emerge at some point and provide that.
But generally speaking, I think, at least in the Rust ecosystem, it's accepted as a fact that huge C code bases exist and they're not going away. I mean, that was
Absolutely.
a goal designing the language to interop with C. And the point I'm aiming at is I fundamentally believe, and I think Google has written, the Google Android team has written about their memory safety strategy. I fundamentally believe that making the existing C code safe and focusing on writing new code in memory safe languages is, at least in terms of return on investment, the better strategy, because essentially the assumption they have underpinning this is that existing C code has found most of its memory safety issues yet. So rewriting it is just a risk for no gain. I would rather see ThreadX in C binding to memory safe languages as the path forward than rewriting ThreadX in a memory safe language.
And this is the perfect cue for the next presentation, because our friend from Valtech is speaking about that.
Exactly. Thank you. I didn't want to kick you out. You did
No,
it yourself.
yes, absolutely.
Thanks, Frederick.
Thank you.
Thanks, Frederick.
Thank you.